Hi there, and welcome to my channel. In this question, we are given function f, which is continuous function defined on the closed interval from -4 to 6. And the graph of f consisting of 4-line segments is shown above. And we're also told that there is function g such that g of x is equal to the integral from 0 to x of this function f. And the first question is, on what open intervals is the graph of G concave up? And so let's take a look at the relationship between G of x and f of t, f of x. G of x is equal to the integral from 0 to x, f of t dt. And let's differentiate both sides to see what we get in terms of the relationship. So G prime of x is equal to the derivative d of x of integral from 0 to x f of t dt. And let's recall how do we differentiate the integral. So let's say we need to differentiate the integral with respect to x, the following integral. Integral from a, which is a function of x, to b, which is also a function of x, f of t dt, which is our case with a simpler function for a and b. And this is equal to f, where we plug in the value b of x, times the derivative of b with respect to x, minus f, where we plug in a of x, times the derivative of a with respect to x. So let's see what we got in our case. In our case, b prime of x is equal to d over dx of the function x, which is equal to 1. And then a prime of x is equal to the derivative with respect to x of 0, which is equal to 0. So plugging it in to the expression here, we get this is equal to fx times 1 minus f of 0 times 0, which is equal to f of x. So we see that the relationship between f of x and the derivative g prime of x is that they're equal to each other. So going back here to the graph, this is actually the graph of g prime of x, which is equal to f of x. And so when is the function in g of x is concave up? The function of g of x is concave up when the second derivative of x is greater, of g is greater than 0. Which means that this is when the first derivative of x is greater than 0, which means that f of x is increasing on that interval. And so let's take a look at this graph. When the function is increasing, it's increasing on this interval from -4 to -2. So the answer will contain the interval from -4 to -2. And then it also increases on this interval from 2 to 6. So the answer will include the interval from 2 to 6. So the answer is -4 less than x less than -2, and positive 2 less than x less than 6. Let's move on to part B. In this question, we are given a new function p of x, which is a product of g of x times f of x. And we need to find p prime at x equals 3. So let's take a look at p of x. P of x is equal to g of x times f of x. Let's differentiate this using the product rule. we get that p prime of x is equal to g prime of x times f of x plus g of x times f prime of x. And so here, then we can plug in values here. P prime of 3 equals g prime of x is f of 3 times f of 3 plus g of 3 times f prime of 3. And let's take a look at these values here. So g of 3 is equal to the integral from 0 to 3 of f of t dt. So we'll need to take a look at the graph and calculate that area. That's area under the curve of f of t from 0 to 3. And then we can just read from the graph f of 3, and then take a look at the slope of f at point 3 to read all the other numbers from the graph. So let's go back and take a look at these values. So the first value, we need f of 3, and f of 3 is equal to negative. F of 3 is equal to negative 3. The second value, we need to look at the f prime of 3, and this value is equal to the slope of this line. And the slope of this line is equal to 1, as we can see. And then we need to look at this area here, which is the area under the curve between 0 and 3. And so this area here, it's positive here on this interval, on this segment, and then it's negative on this segment here, and this segment here. And so we can see by counting those squares that g of 3 is equal to negative 3.5, because the first two triangles cancel out, and then trapezoid has 3 full squares and 1 half square, and it's negative, so it's negative 3.5. So going back here, we can see that this is negative 3.5, and then plug in the values, we can get negative 3 times negative 3 plus negative 3.5 times 1, which is equal to 9 minus 3.5 equals to 5.5. Let's move on to part C. In this question, we need to find the limit of the ratio of two functions, g of x and x squared minus 2x, when x goes to 2. And let's first try to just plug in the values here. And so g of 2 is equal to the integral from 0 to 2 f of t dt. And this is equal to, we can see here that this is area under the curve here is positive segment, and then this segment is, this triangle is negative. So overall, we can see that they cancel out, the area is the same, so g of 2 is 0. So let's plug it in here, we get it's 0 over, and then plug in 2 in the denominator, we get 2 squared minus 2 times 2, which is 0 over 0. So we have to apply, we can apply L'Hopital's rule here. So let's use L'Hopital's rule, which states the following. It states when we have the indeterminate limit like that, 0 to 0, then limit of the two functions as x goes to x0, f of x over g of x is equal to the limit as x goes to x0, and we just differentiate the numerator and the f prime of x here and g prime of x in the denominator. So let's then take a look here at our case. Limit as x goes to 2 of the g of x over x squared minus 2x, differentiating, this is equal to the limit as x goes to 2, g prime of x is f of x, and differentiating the denominator gives us 2x minus 2. So let's now try to plug in the values. This is equal to f of 2 over 2 times 2 minus 2 is 2. And so let's read f of 2 of the graph here, and f of 2 is equal to negative 4. So plugging it in here, we get negative 4 over 2, which is negative 2. So the answer here is that this limit is equal to negative 2. Let's move on to question D. And so in this question, we need to find the average rate of change of G on the interval from negative 4 to 2. And then we need to see whether the mean value theorem applies and guarantees that there is such a value C from this interval for which G prime of C is equal to the average rate of change. And so let's first recall what is the average rate of change. The average rate of change is equal to, for the interval from A to B, this is equal to f of B minus f of A, the value of the function at 8 points divided by the length of the interval. So in our case, the average is equal to G of 2 minus G of negative 4 divided by 2 minus negative 4. And so let's see what G is equal to at these points. So G of 2, as we just saw, is equal to 0, and G of negative 4 is equal to the integral from 0 to negative 4 f of t dt, which is equal to negative, and we just change the order of integration here from negative 4 to 0, f of t dt. And so let's go back to the graph of function f and count the number of rectangles here to calculate the area under the curve. And so we need this segment here from negative 4 to 0. And let's break this into 3 segments, 3 areas. Area 1, area 2, and area 3. And we can see that area 1, A1, is equal to, this is a triangle with base 2 and height 6. So the area is 1/2 2 times 6, which is 6. And we can just do it by counting the squares here as well. Area 2 of this is triangle with side 2, base 2 and height 2 as well. So the area here is 2. And then A3 is just a rectangle with sides 2 and 4. So this is equal to 8. So overall, this area is equal to 6 plus 2 plus 8, which is equal to 16. So getting back here to our integral, this is equal to negative 16. Plugging it back into our expression here gives us 0 minus negative 16 divided by 2 minus negative 4, 2 plus 4, 6. This is equal to 16 over 6, or this is equal to 8 over 3. So the average rate of change is 8 over 3. And let's see whether the mean value theorem applies here. And it does apply because G is differentiable function, differentiable. differentiable on interval -4 to 2, and therefore it's also continuous on this interval. Therefore, the mean value theorem applies, and it guarantees that there exists such a value C, that G prime of C is equal to the average rate of change, which is 8/3. Thank you for watching. If you liked this video, please don't forget to click the like button, write me your comment in a space below, and subscribe to my channel where you can find more solutions to the Calculus AB and Calculus BC problems. And I will see you in the next video.